I'm very excited to give this project obstacle distance measurement by using ultrasonic sensor board friends. It will try to produce 20 kHz sound and receive and convert into the electrical signal for measuring the distance friends, and where a distance is equal to speed into time friends, where speed is equal to 340 meter per second friends. Hi friends, welcome to our channel. So for this project we required Arduino Uno R3 friends. So you can see, and this is the Ultrasonic SC-SR04. This is the daughter board friends. So we need to have this one. And in this project we are using the 2 cross 16 LCD with an I2C adapter soldered onto it, and 4 wires it has been taken out of it. So the LCD, and in order to connect the rest of the things we need to have it as a breadboard friends, and we need to have it as a connecting wires. We need to have the connecting wires friends, and we need to have a USB A to B in order to flash and get the power from the laptop or in a desk. Arduino Uno and connecting over here friends, and I'm taking the LCD and I'm connecting to the friends. So the first, now if you can see the connections, the first one is the ground, so I am keeping the ground onto the here friends, or you can see the ground 2 pins are there, and the second one will be the 5 volt, so I am keeping onto the here friends. And now you can see the SDA, the SDA will be the yellow, that is nothing but the A4, and SCL it is going to A5. Now let me turn and putting onto this side friends. Now I am taking the ultrasonic daughter board. I am taking the 4 wires. The first one will be the, now we can see the first one will be the VCC. So I am taking to the red and I am connecting over here. And the second one will be the trigger. So I am taking it to here and I am giving on to the 11. And the third one will be the trigger. Sorry, it is echo. I am giving on to that one. And the last one will be the VCC 5 volts. I am taking to the wire and hand over into here. Because we have only 5 volts from the board, so I need to have it as one more wire. Now I have only 5 volts from the board, so I am taking the 5 volts here and I am giving on to the extend to the here friends. So now if I am turning the board towards you, it looks like this friends. So because we want to see the display and this. For this project we need certain libraries friends. For that I am going to the sketch, and there we need to have it as include library, and I am going on to the manage libraries, and here I am typing new ping. So this is the new ping library we need to install in order to work with ultrasonic sensor. And the second one will be the liquid crystal underscore I2C. So if you scroll down, you can see the liquid crystal I2C. So these two is a mandatory friends. By the code, now I put it onto the text and let me upload to the GitHub, and I will give the description in the video. So I am copying this one and I am pasting onto here. So if you come over here friends, so the liquid crystal I2C LCD address, number of characters and number of lines. In 2 lines, in each line we can write 16 characters. So first one is new ping.h, we have included liquid crystal underscore I2C.h. So these two things is a mandatory friends. Without that the code cannot be compiled. The trigger pin will be the 11. So here you can modify the pin numbers which are connected to the ultrasonic board friends. So this is the thing, and we are also initializing serial port. And for the LCD.init backlight set cursor, and the very important things when you want to write on the LCD, that is LCD.print. So now if we are coming onto the loop, it's LCD.clear. We are getting the distance by using ping underscore cm. So which you already is the distance we can get in centimeters, and we are printing the same information on the serial port, and we are printing information onto the display LCD, that is LCD.print friends. So hope this is the code, and we try to give this one in the description, putting this code on the GitHub. And when you want to modify the trigger pin and echo pin, here you can come and modify it. And the LCD, if you have 2x16, you can use it. If you have a 4x20 or any other configuration, you can use it. And the I2C address also you can modify here, friends. So this is the one. And now let me go to the sketch, verify and compile. You can see it, friends. Now I was dragging this one to GitHub, you can see, and the sketch I was uploading, friends. This code I'm uploading to it, so you can see uploading is done.
Now let us see some couple of an experiments, friends. Now the object is placed at 5 to 6 centimeter. The display is showing. Now it has moved to the 12 centimeter. The display is also showing 10 to 12 centimeter, friends. Now we try to repeat the same with a different object. So now we have placed it as in 5. Now you can see it as 5 centimeters, friends. So for more information, please like and share, subscribe to our channel, friends. That will help me a lot, friends.